Welcome back to another episode of Mr. Warren's Audio Hood. And please welcome our special guest, Dr. McQuack, from the McQuack Hospital and Microwave Hair Removal Clinic. Ladies and gentlemen, Dr. McQuack, welcome to the show. Thank you very much, and thank you for having me here. We all know that your hospital is well known for breast augmentation, tummy tucks, chin lifts, and while I'm certain most of our viewers understand those things, what exactly is microwave hair removal? The lawyers won't let me tell you that. The lawyers? You know, those guys. Were you killed in a car crash? Did you get run over by a bus? Did you OD on drugs? One call does it all. Dewey, Cheatham, and Howe, Esquire. We'll throw the book at them, and we got a bunch. Yeah, they spend a lot of money on ads here. Yeah, and where do you think they get it? They're spending my money. Your money. Yes, every time some woman wakes up with 3 breasts, we get sued by those guys. So yes, it's my money. We were running a special. Buy 2, get 1 free. Such a deal. Special. I'm sure it was very special. So what else do you do at McQuack's Hospital? In addition to body modifications and enhancements, we also do a lot of soldering. Soldering? Of course, soldering. How else do you think we make a nose ring permanent? But what's really important is that McQuack's Hospital is a teaching hospital. We have internships and full residencies in solderology. As a matter of fact, I brought along some of our training courses in soldering as a sample. Okay, Phil, roll the film. Phil? The tape guy's name is Bill. Phil, whatever. Welcome to training film number 105 in the McQuack Hospital training series for solderology. This is a typical professional-grade, temperature-regulated soldering station. This is a more economical soldering iron, typical of what you might want to carry in a typical small toolkit, perfectly suited for basic work. This is a pair of automatic wire strippers. While not absolutely necessary, they are nice, efficient, and a precise way to strip cable. This is a pair of diagonal cutters, also often referred to as dikes. These are industrial-grade, inexpensive, but rugged. This is a pair of precision diagonal cutters. This is a pair of high-precision, fine-tipped needle nose pliers. This is a type of vise, often called a third hand, which is great for positioning small parts. This is a more heavy-duty, miniature bench vise. This is another example of a third hand device, but with a magnifying lens. This is a roll of solder wick, which acts kind of like a sponge for removing excess solder. Typically, it's more useful for working on printed circuit boards and things like that than it is for connectors. This is a device called a soldapult, which is basically a small vacuum solder removing tool. You use it by pushing the plunger down, heat up the solder you wish to have removed, press the tip of the device over the solder, and push the release button, and the excess solder is sucked up inside of it. This is a heat shrink gun. Basically, it's a hair dryer on steroids that puts out about 800 degrees. It's used for shrinking heat shrink tubing. This particular one actually is nothing more than a paint remover, but it does the job. This container is filled with solder flux. It's the same chemical that's actually inside of rosin core solder, but with an alcohol base. It's useful when soldering to heavy gauge materials and sometimes for helping to make some dirty materials solderable. It's also very sticky, but it can be washed off with alcohol. These are some pieces of heat shrink tubing, which is used to protect some connections. Of course, no soldering class would be complete without solder. This is a roll of lead-free solder. It's a mixture of tin and silver. It's rosin core solder. Quite often, hardware stores will carry some solder, but more often than not, it's acid core solder, which is intended for plumbing work and should never ever be used on any electronic connections at any time because it continues to remain corrosive for years. This is a properly cleaned and maintained soldering iron tip. Using a soldering iron tip that is corroded and covered with dirt and oils can lead to contaminated and unreliable connections. This is an example of a very dirty, corroded soldering iron tip. It has a lot of carbon contamination, which can sometimes get into your connections. This tip can be cleaned with a small file and some steel wool and perhaps a bit of alcohol. It's always a good idea to keep a small cellulose sponge wetted with water nearby when soldering so you can continually clean the tip of your soldering iron, as bits of rosin and other stuff will accumulate on it as you're working. We will begin by prepping the cable that we intend to use for our connectors. We will start by stripping off the outer jacket with a pair of automatic wire strippers. While a regular pair of cutters can do the same job just fine, the automatic strippers are quicker and more precise. Once we have removed the outer jacket, we then remove the inner fiber fillers, these little thread-like things, using our cutters. After that, we need to strip back the insulation on the actual conductors. It depends on the type of insulation, but an 1/8 inch strip length is usually sufficient with this type of PVC jacketed cable, as it will shrink back a little bit once it's heated up. Next, we need to tin the ends of the wire. This makes it easier to solder into the connector or anything else, as the tinning process coats the surface of the wires with solder, and with stranded wire in particular like this, the wire will wick up a certain amount of solder inside. It does not require a lot of solder, just a thorough coating. You will observe the insulation shrinking back slightly as the inner conductor is heated up. Now we will tin the contacts on the XLR connector. You will notice that this particular connector has machined solid metal contact pins, which is actually quite typical of most connectors with male contact pins. This also means that it takes a bit more heat and a bit more time to heat the solder cups sufficiently so that the solder will melt and stick to them. If you have made a mistake of buying Chinese knockoff connectors, quite often to get the pins hot enough for the solder to melt and stick to them, the plastic pin block, also called a substrate, will often melt, and sometimes the contact pins will just fall out. You do get what you pay for. I noticed after I tinned the cups that they needed a bit more solder to have enough for a solid connection, so I'm continuing to add enough until I see enough in the cups. Typically, it's advisable at the very least to sleeve the bare shield wire. This is done in case over time from movement and twisting the shield strands tend to fray, and the sleeving keeps them from fraying and from getting loose and then making contact with the other pins. I prefer to use this particular silicone sleeving material because it will not melt, but heat shrink tubing is quite sufficient for the same task. We will now solder the cable to the XLR connector. The shield, or drain wire as it is sometimes called, always goes to pin 1, sometimes simply called the ground pin. The red wire, typically the audio signal hot lead, always goes to pin 2. And the black wire, the audio signal cold lead, always goes to pin 3. Notice that the pin numbering runs in a counterclockwise direction on the solder side of a male XLR connector and clockwise on the solder side of a female connector. An easy way to remember this without having to overthink it is this: boys on the right and girls on the left. That's because on a male XLR connector, the number 1 pin is on the right-hand side, and on a female XLR connector on the contact or solder side, the number 1 pin is on the left. You will notice that there is a solder tab on the top center of an XLR connector. This is used for situations where the outer shell of the XLR connector needs to be connected, typically to the shield, if ever. This is typically actually neither required nor recommended, as doing so can actually create an internal ground loop within the cable. You could, however, do this only at the male end of the connector, particularly if you have a situation with serious radio frequency interference. Otherwise, just do not connect that tab. We will now solder the other end of this cable to a female XLR pin block. The cable was prepped ahead of time so as not to beat the dead horse unnecessarily. You will notice that I turned this connector upside down and horizontal. You will also notice that the solder cups are made from a thin stamped metal sheet versus a solid machined cup. Since all female contacts are also referred to as sockets as opposed to pins, which are male contacts, you will also occasionally hear that distinction made very clearly with military-grade connections. They're either pins or sockets. But back to this. Because of how these sockets are made, with some connectors like this, if you position the connector vertically, the solder can run down into the actual socket itself and then plug it up, rendering the connector unusable and unrepairable. For this reason, positioning it as I have solves that problem. Once we have soldered the pins and tinned them up, we will flip it over in the correct direction to actually attach the wires. Once the entire connector is soldered together, we will slide a larger sized piece of heat shrink tubing over the entire thing. This adds a little bit of corrosion protection and reinforces the strain relief collar once we put that into place on the connector itself. Here are the two finished connectors side by side. As I described, boys on the right, girls on the left. This connector is a somewhat ancient oxidized connector I found laying around in a parts bin. As we attempt to tin the first contact pin, you can observe a layer of dross and grime that has formed between the solder and the surface of the solder cup. This can make for a very unreliable connection. In fact, more often than not, sometimes they will just pull right back out. So to make a connector like this usable, the contact pins would have to be cleaned. The best tool for this is a small needle file, like you can find in a hobby shop for working on model airplanes and things like that. Here you can see me gently scraping the grunge off the surface of the inside of the contact pin. As I say, gently, because most contact pins are plated with either a thin layer of silver, in this particular case, or gold. If you scrape too much off, you may expose the base metal, which may or may not take solder very well. You will notice that as I solder the other two pins, there is none of that dross and grunge layer between the solder and the solder cup. This is an example of a cold solder joint caused by the wire not being still while the solder is cooling, or the iron not being held on the contact long enough, or being too cold. You will notice a slightly grainy spot on the surface of the solder. This is a classic example of a cold solder joint. You will notice a large patch of grainy, dull area on the surface of the solder, which should be otherwise shiny and smooth. A large enough cold solder joint like this can actually simply pull right back out of the solder cup. This example is a failure waiting to happen. This wire has barely enough solder to attach it to the solder cup. This will break free of the connector pretty easily. Sometimes, when repairing old cables, it's best to replace the solder in the existing connector, assuming the connector is in otherwise good condition. This is advisable simply because of the dirt and oxidation and oils that can be built up in the old solder. This is where the solder pult is most useful, as demonstrated. Wow, we certainly learned a lot from that now, didn't we, folks? Oh, what the hell was that? It was a TIE fighter. We seem to have a bit of an infestation. No, that thing you put in your pocket there. You're gonna put your eye out with that. What are you, Miss Sugar? It's a pocket lightsaber. Infestation? Lawyers? TIE fighters? It's more like a plague. Oy vey. Well, that's all for this episode. Please thank our guest, Dr. McQuack.